So right, so rules for exponents. Now this is basically like year 8 power stuff. You've seen it all before. So the first one is for multiplication. So that's when you've got a base a to the power of m times a to the power of n. Without cheating, looking at the sheet, what do we do with our powers? Add them. Oh, Troy. Just making sure everyone else is awake. Okay, good. Yeah, add them. Okay, second one is division. So a to the m divided by a to the m, which you might also see written as a fraction. What do we do with the powers? Minus them. M minus n. That is what order it goes in. It's not n minus m, m minus n. The third one is powers to another power. So we've got a to the m and then take that to the n. What do we do with the powers? Times them. Good. Mn, or m times n. If we have a times b to the power of n, what does that become? Yeah, a to the n times b to the n. Or a to the n, b to the n. No, it's just that. Then we've also got a divided by b to the n. What happens when we take a fraction to a power?
You put it on both.
Yeah, take the top and the bottom to that power. So a to the n over b to the n. That's essentially all the rules you need to know.
It's from that. On that.
Examples. Start off with something super simple. 8 to the negative 2, write that in simplest exponent form. I think that's how you say it, exponent, exponential form. Simplest power form. Yeah, so we know that a negative power puts it 1 over 8 squared. Can we simplify 8 squared into something even simpler? Not a single number, we want it in like simplest power form. So we want to make that base as small as possible.
Oh, if you go...
The number 8, can we change that?
2 cubed squared?
Yeah.
How's that simpler?
Hold on. Okay, what do we know about numbers that are taken to the power? Times them, yeah? 1 over 2, 3 times 2 is 2 to the 6. So that's in simplest power form. Okay, the other one, oops, not 1/4, 1/2 to the negative 4. Yep, so you can bring it into the 1 and to the 2. What's 1 to the negative 4? It's just 1. 1 to the power of anything is just 1. So we get 2 to the negative 4. What is this negative, when you're talking about whole numbers, what does a negative power usually do? Puts it under a fraction. So if you've got a negative already under a fraction, it does the opposite, brings it back up. 2 to the 4. 3 to the power of 2n times 6 to the n over 8 to the n times 3 to the n. I'll give you a hint. What you're aiming to do is get all of your numbers in terms of a base of 2 or 3. Right, so 3 to the squared n, how would you say that? 3 to the 2n. We can write instead as 3 to the n squared, because you just multiply those to the 2 and the n, which will give you 2n, just like up here. And 6 is a 2 times 3 to the n. 2 times 3 is 6. 8, how can we represent 8 as a base of 2 or 3? Sorry? No, just a base of 2 or 3. 2 to the power of 3, yeah. N times 3 to the n. Okay, this one, 2 to the 3 to the n. Because what we're kind of seeing is that we've got 3 to the power n, we've got 3 to the power n, this has got to have a power of n. So we're seeing that, and our bases are going to have powers of n, and that's going to help us cancel out top and bottom. So what I'm actually going to do is change this power here to 2 to the n cubed. It means the same thing, because then you just multiply the two powers, get 3n. It was 2 cubed to the n. It's exactly the same as 2 to the n cubed, because you just multiply those two powers to get the exact same number. Okay, what do we know about on top here? 2 times 3 to the n. What do we know about two numbers multiplied together and then taken to a power? It's one of the rules. Yeah, you just take in that power into both numbers. So we have 3n squared, so we've got 3n times 3n. We've got 2n times 3n. That's that bit there, 2 times 3 to the n. Over 2n cubed, so we've got 2n times 2n times 2n, and then times 3n. Now we can cancel out. So we've got 2n from top and bottom, 3n from top and bottom. So we're left with 3n times by itself, so that's 3n squared, over 2n times by itself, so that's 2n squared. We can see they both have the same power, so we've got 3 to the 2n over 2 to the 2n. What can we do? Both the top, the numerator and the denominator have the same power? Take it out and put it in brackets, yeah. So 3 over 2 to the 2n. And that is the simplest form.
Well, you know, you guys are just sitting there like couch potatoes and not helping the cause.
Okay, rational exponents. This just means fraction powers. Now the rule we should all know by now, a to the 1 over n is just the nth root of a. Or if you've got a different number on the top, not a 1, a to the m over n. The n is the nth root, and then your m is your power. Or, of course, you can write it the nth root of a to the m inside the root. Nth root, yeah, like cubed root, fourth root, fifth root. So we've seen that pretty much the whole year. So 9 to the negative 1/2. What's the negative do?
Puts it underneath.
Puts it under a fraction, yep. What's a half? Power of a half? Yep. So of course 1/3. Pretty easy. Try this one. 16 to the 5/2. Be square root 16 to the 5. Of course, you can have your 5 power inside the square root bracket, but this way I think it just makes it easy because we can see already square root of 16.
So it's the same.
Yeah, 4 to the 5. Which is 1024. So yeah, if you had chosen to take this 5 and put it inside the square root, obviously would have made things a lot more trickier because you have to do 16 to the 5 and then square root it. You would have ended up with the same answer, but of course we can calculate square root 16 much easier than we can do square root of 16 to the 5. Uh, 64 to the negative 2/3. What's a negative do? Puts it under a fraction, yeah. 1/64 to the 2/3. Denominator is your root power. Top number is your square power. No, root power. Root number. Yeah. So we get cubed root of 64 squared. What is the cubed root of 64? What three numbers are the same multiplied together gives you 64?
6, 8, 4.
Yeah, cubed root of 64 is 4. And then, of course, 4 squared is 16. Okay, slightly bigger and harder one. 3 to the quarter times square root of 6 times 4th root of 2 all over 16 to the 3/4. So just simplify what you can. We don't like square roots, so try to get rid of them by turning them into a power. Always try to change your fraction powers back into square roots if that helps you cancel. In this case, it doesn't. So 3 to the quarter. Square root we can represent by not 4th root.
I was talking about this.
1/2. Square root we can represent as power of a half. Yeah, 2 to the quarter over. Now this one I'm going to actually change because what we found is if we do the 4th root of 16 cubed, what's the 4th root of 16?
2.
Yeah, 2. So it's easily 2 cubed. So we get 3 to the quarter. This 6 we can change into a 2 times 3 to the half. 2 to the quarter. That was 2 cubed. Now this 2 times 3 to the half. We can obviously take the half and multiply it in. So we get 2 to the half times 3 to the half times 2 to the quarter over 2 cubed. All right, now we've got 2 3s on top and 2 2s on top. What happens when you multiply numbers of the same base? Add the power. Yeah. So we've got 2 to the half and 2 to the quarter. So that gives us 2 to the 3/4. Half and a quarter makes 3/4. We've got a base 3 and base 3. We've got a quarter and a half. So again, 3 to the 3/4 all over 2 to the 3. Now what? We want to somehow combine these two numbers here because we've got both a base of 2. We can't combine them. Technically, you can combine them right now because they're division. So you could minus the powers. Or what we can actually do is take this top one, make it a negative in front and put it down the bottom.
How can you just make it a negative?
Because we know when there's a negative power, it puts it on the bottom of a fraction. So 2 to the 3/4 on top is the same as 2 to the negative 3/4 on the bottom. So we can leave our base 3 on top and change the top base 2 to the bottom by putting a negative in front. Yeah, because you've got a negative on the bottom, it's actually the same as a positive on top. Now, we've got two numbers here that are base 2 that are being multiplied together, so we can add the powers. So 3 take 3/4 is 2 1/4, which is 9/4. 9/4. So yeah, probably keep it like that. You could go further and make these fractional powers into 4th root 3 cubed and 4th root 2 to the 9, but you know, they both mean the same thing. One's neither simpler than the other. So that one's done. Okay, last one is x to the negative 2 times y to the 1/2 times x over y to the negative 3 to the power of 4. First things first, what do we do with these bracket powers?
You times it in.
Yeah, times it in. So, x to the negative 2 times 1/2 is? Yep, y to the 1/2 times x to the 4, y to the negative 12. We've got essentially a whole number and a fraction. How do we multiply a whole number and a fraction? Times the whole number onto the top of the fraction. Just like how you do with numbers. Like if it was 6 times 1/2, right? You'd multiply that 6 on top. Yeah. 6 over 2. Right, so that's all you do. So you take this whole number here and multiply it on top. So we get x to the negative 1 times y to the 1/2 times x to the 4 over y to the negative 12. What can we do with this x and this x on top? Add them. Good. So x to the 3 times y to the 1/2 over y to the negative 12. What do we know about this y to the negative 12? It's a negative on the bottom of a fraction, so what's it the same as? Put it on top, get rid of the negative. x to the 3 times y to the half times y to the 12. The y and y, add the powers. 12 and a half is 25 on 2. 12 and a half. Yeah, 24 plus 1, 25 on 2. Wait, 20. So suppose you, yeah, 25 on 2. I was getting a bit confused. 25 on 2. And that's it for that one. Of course, you don't need to write them their times. You can leave that out if you wish. So it could be x cubed y plus 25 on 2. But, you know, either way, it means the same thing.